Okay, now we go to my absolute worst. I was going to say favorite, but it would be so sarcastic, is the Galapagos Islands and Darwin's finches and Darwin's tortoises, and now we're going back to Darwin's finches. People, make sure that you know that on the Galapagos Islands, you see Darwin packed up and he said bid his wife farewell, and he bid all his family farewell, and he went off on a 5 or 6 year little excavation process where he went to these islands. And on these islands he noticed these horrible, ugly little birds. They were gray, uninteresting little birds, but there were lots of them, and they, on the different islands, they had pretty much the same physical features, but their mouths were different. Now, we all have learned through many years, and common sense will tell you that depending on what a bird's mouth looks like, that will determine what it eats. Okay, so if I have an eagle is going to have a nice big curved beak that it can rip that flesh apart and eat it, okay? Whereas a chicken walks around the back garden, goes gip, 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 and picks at little bits of seeds and worms and rubbish that you find lying around. Okay, very different. So the bird's mouth parts and its claws and everything determines what it eats. A canary doesn't eat the same food as a parrot, for example. Common sense. Okay, this section, really, honestly, as far as the evolution section is concerned and the diversity section in your books, make sure that you know the difference between a primate and a human being. What being bipedal means, in other words, the fact that we have 2 legs, bipedal. Bi meaning 2 pedal, well, you need 2 pedals on a bicycle, so 2 legs. And Darwin's theory of natural selection, that's all he said, that we come from a common ancestor, number one, and number two, that it was because of natural selection that we ended up with where we were at. So we go to these ugly little finches, which they make such a big thing about, and you are guaranteed a question on Darwin's theory of natural selection using these stupid finches or tortoises of some sort. They love giving this kind of question. You'll get something that gives you a data response. Just please know that all these little finches, these ugly little plain birds, came from the mainland, and they were then divided by a barrier of water because they ended up on the islands. So if we look at the different barriers, you get allopatric and sympatric. Okay, allopatric is when there is a division which is a physical barrier. So we're looking at water or mountain range or something like that. There is a physical barrier that these animals cannot get together. Allopatric, remember? Allopatric, sympatric. Allopatric, big barrier, physical thing in the way, which separates the species, the same species, and they will then adapt to survive. So when you bring them together a couple of years later, they cannot interbreed because they are now too different. So all the little microevolutionary changes ends up being a macroevolutionary change. Microevolutionary change, little bits and pieces of change. Macro, huge. All right, here we go. Sympatric, by the way, changes based on reproduction. So you have reproductive isolation. I forgot to say that. So your allopatric, big physical barrier, sympatric, reproductive isolation. Okay, here we go. The graph below shows their data of one finch population. So here are our famous little ugly birds. Finch populations. A finch is a mossy. Okay, in case you didn't know. On one island for a period of 7 years. So let's have a look. Clearly these people had too much money on research. They could have spent this on HIV/AIDS research. But instead they did a whole bunch of little ugly birds on an island. So they give us the key here. So this here is our rainfall in millimeters. So it has pretty much the same rainfall all the way through. I'd say it's about there. So it's a bit more than half. So to be 100, I'd say probably 120 mils of rainfall all the way through. But then in 1997, there is a drought, and this is exactly what you're going to do on the question in an exam. You're going to write on your piece of paper. So you write there must have been a drought. Why? Because the rainfall drops to naught or just above naught. Okay, and then the rainfall goes up to normal again. So there it's normal, and then it decreases again. So there's the rainfall, okay? So now clearly, the rainfall decreasing is going to have an impact on the amount of food that's available for this bird. That's common sense, people. That's logic. Little bit of rainfall, less little seeds are going to be around. Now, the minute there is lack of food, what impact do you have? Well, guess what? Hello, there's more competition. So the animals are going, those that aren't strong enough are going to not get enough food, and they're going to do what? They're going to starve, and if they starve, they die. Can they pass their characteristics on to the next generation? No, because they did. All right, so here we go. You see, common sense, just common sense. Okay, we look at the line with a little X along the way. That's the number of finches. So happiness is 1974, there are 1,200 little finches. And whoa, look at this. In 1975, there are 1,400 finches. Everything is moonshine and roses. And then clearly the population decreases here because there is competition for food. And it's just more than the carrying capacity. So we can say 1,200 is approximate carrying capacity of that area. Okay, so this is just natural, increase, decrease, increase, decrease, so you have a fluctuating stable population. Except, look what happens. In 1977, there is a drought, okay? Now, this drought causes a huge decrease in the population. Why? Because these little things starve. Okay, there isn't food. There's no food to eat. Drought, no seeds, no seeds, no food, they die. Quite simple. Those that survive here are about 200. In fact, it's just a bit lower. I'd say probably 180 of these little finches survive. And then they reproduce because there's more food and everything gets better, and they go up to about 400. And then again, as the water level decreases and the rainfall decreases, so the food will decrease. Therefore, food decreases. Okay, and if the food decreases, so does the number of birds again. So it drops down, but not quite. It drops down here to about 200 birds. Okay, now if we look at this line here, we've got the number of small seeds in milligrams per square meter. Now we've already said logic will tell us that as the water levels decrease, as the rainfall levels decrease, so the seed level is going to decrease. So now look here, lots and lots and lots and lots of little seeds, up to 800, and everything's hunky-dory, and then the water level, the birds eat it, because the bird population is high. Then as the bird population dies down, so the level of seeds also, because they've been eaten. But then there's a drought, so zhoops, down come the seeds again. Now there's a bit of rainfall, we have more seeds, and then again, as the rainfall starts to decrease, so the seed levels start to decrease. That, in a nutshell, is what you are seeing on this graph. When you do something like this and you get a question like this, people, anything on your exam paper, if there is a diagram, put in the labels. If there is a graph data response question like this, for example, you are going to write all this information out. Now, clearly it's taken longer because I've been explaining it. For you, on your own, in an exam, quick, you just make little notes for yourself. Right, now we look. Explain the relationship between the number of small seeds and the amount of rainfall. Easy. As the rainfall decreases, so the number of small seeds decreases in milligrams per square meter. There we go. End of story. Next question. Use Darwin's theory of natural selection to explain why the number of finches fluctuates on the Daphne major island. Okay, why do they fluctuate? Because everything is good, rainfall is good, enough food. So at this point, there is enough food. Okay, so in 1974, there is enough food for the finch population. As the finch population increases, because life is good, so the seed population increases as well. The water population stays stable. But remember that in order for a plant to produce seeds, it has to grow. And where does it come from? It comes from a seed. So if there were lots of finches, they would have eaten lots of seeds, which means less seeds would have been allowed to grow to maturity to produce more seeds in the plant. So we have as the finch population increases, so the seed population is going to, the seed population increases slightly. Then the finch population increases, causing a decrease in the seed population, which in turn causes a decrease in the finch population. And then we have a lack of water in 1997, which causes an incredibly high decrease, or a huge decrease in the number of small seeds that are produced, okay, which directly influences the population of finches. And yeah, well, that's the end of that one. So it was, again, people, all you need to do is make sure that you analyze what is in front of you. Have a look at it. Don't think of it in terms of, woo, have I learned this biology? Maybe you haven't. Maybe you've never ever seen it before. Just use your common sense. As the population increases, all right, those birds are going to eat the seeds. If they eat the seeds, there are going to be less plants that are going to produce more seeds. If there is less rainfall, there isn't enough water for those plants to grow. And if there isn't enough water for the plants to grow, well, then we have a big problem there as well. Okay, I'm just going to see if we have any more questions that have been put on here for us. Let's just have a look at what this one is. Okay. This is adapted from the September 2011 National Senior Certificate Paper 1, question 2.3. So what we've got here, and people, we're coming to the end of our session, so we've got about 10 minutes. I'm going to work through this as quickly as I possibly can. Okay, study the diagram below showing the effect of antibiotics. Now, common sense again tells you that we know that if you get given an antibiotic, it is to fight bacteria that you have in your body. And you are told from the time you can walk by your mother, who was told by her mother, who was told by her mother, that you always finish your antibiotics. Why? Because if you don't finish your antibiotics and just one bacteria survives, remember, and I just want to show you here, bacteria grow like this. If this is the population size, and this is time, your bacteria go from 2 to 4 to 8 to 16 to 32 to 64 to 128 to 256 to 512 to 1024. Now look at this. And after it's 1, 2, 3, 4, 5, 6, 7, 8 multiplications, and you go from 2 to 1024. Not bad. I wish we could do that with money. So your bacteria starts here and it goes like that. And you kill it. This is when you take your antibiotic. If only one little bacteria survives, what happens? 2 becomes 4, becomes 8, becomes 16, becomes 32, and so we carry on to 64, and you now have to get another antibiotic. The chances are that this one that survived, because they survived, they build a resistance to that antibiotic, so you're going to have to take another kind of antibiotic. So you always take your antibiotics to the end. You have to wipe out every single one of these bacteria. You've got to make sure that there isn't even one that makes it, that they are all dead, dead, dead. Okay, so here we go. They show us here. Study the diagram below, showing the effect of antibiotics on the bacterial infection in a human. Okay, antibiotics have been administered on day 1 and day 2 on a 5-day course. All right, it's a 5-day course. So on day 1, this is before administration of the antibiotics. We've got our little bacteria. And then after the antibiotics, this is what we get. So we've got 1, 2, 3, 4, 5, 6, 7. We take antibiotics. We've got 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 of them. Now, I'm not sure if the fact that they now have taken out parts of this here and do it like that. Okay, so what are we doing? The antibiotic is wiping out, it's slowing down the reproductive process of the bacteria. Here we're going to see that the second day we now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've gone from 13 here to 12. Our antibiotic is now starting to kill them off. Okay, which bacteria, A or B, is resistant to the antibiotics? Okay, so this is what they've done. B's are all the way around, and this would have been there. That's day 2. So day 1, we've got these bacteria. So the lines missing there was worth something. So here we've got 13, of which we've got 12 that are normal, and we have 1 other. And here we've only got the 12 that we started off with that have now increased in size. So the antibiotic has now destroyed all of the A bacteria. Okay, so which bacteria, A or B, is resistant to the antibiotics? It is going to be B. B is resistant. Why? Because all the A's are now dead by the end of day 2, and not the B's. I mean the A's. Okay, so I'm going to do this. It makes it easier for us to see. This is really a silly way of drawing it. I sometimes wonder if the people who set these exam papers bother to read them a second time. Anyway, explain the effect that the antibiotics have on the bacteria after the first day of treatment. What effect can you see here is that the antibiotics are now working on the bacteria A, and it is killing off bacteria A and preventing it from reproducing. Because at the end of day 1, we have 1 bacteria here that is A. We only have 1 A, and on day 2 we still only have 1 A. But by the end of day 2, there are no A's at all. Okay? Name the process that is represented by the arrows labeled X. This is the working of the antibiotic. In other words, this is as the antibiotics are now functioning and working on the organism. And let's see the last. Explain what would happen if the person stopped taking antibiotics on day 3. Well, you would have killed all A, the A bacteria, but the B bacteria would still have survived. And if the B bacteria survived, they are going to continue reproducing, and your body is that you are not going to kill them. And you will just get sicker and sicker and sicker again. All right. And I think we're running out of time at a rapid rate. Use the information of that diagram to explain mosquitoes may become resistant to DDT. In the old days, we used DDT to kill mosquitoes. And a couple of mosquitoes each time survived. So what they did was they interbred. And with that interbreeding, if you look at, remember our crosses, and if we take a cross, all right, and we've got our cross. So let's say we've got heterozygous mosquitoes. And this mosquito here, the homozygous recessive, these are the mosquitoes that are resistant. So every time there is breeding that takes place, okay, the antibiotic, or at least the DDT, will kill off all these mosquitoes. And it's going to kill a whole bunch of these as well. But a couple of them will survive and breed to produce these. Eventually, we end up with this taking place. And we end up with 50% of our mosquitoes being resistant. Until eventually, those are the mosquitoes that survive. And then the DDT doesn't work at all. Okay, so people, remember, that is how we breed resistance, and that is through natural selection. So humans have taken natural selection, looked at the processes, and then started genetically modifying organisms. And with DDT, the biggest issue with DDT, it was eventually put on the black market, or it's sold on the black market only, because it became a banned substance. Why? Because it was not biodegradable. So it would kill mosquitoes and eventually was ineffectual on mosquitoes, but affected the rest of nature and the rest of everything that was around it, because it is non-biodegradable. It changes mental patterns and the way organisms work. So it's not good stuff. All right, so that's where we are going to finish off today. I think I've got like about 3 seconds left. So good luck, enjoy. Please contact us, send to helpdesk@learnextra.co.za, Facebook us. We'll deal with your questions as they come in. And people, use your common sense above everything. Learn your work, but use your common sense when you answer your exam papers. It's all there. You will do well, I promise you. Just learn the facts and know how to use them. Have a good one. Enjoy the rest of Saturday afternoon. And let's hope New Zealand thumps Australia tomorrow, just because Australia did what they did to us and their stupid Bryce Lawrence. But at the end of the day, let's all shout for New Zealand. At least then the Australians don't get it. Have a wonderful, wonderful Saturday afternoon. Until next time, bye-bye.